going to be covering the solutions from exercise 1.1 from chapter 1, real numbers. So the first question, they've asked us to express the given numbers as a product of its prime factors. In order to express a number in its prime factors, we need to perform prime factorization through the method of long division. So the first question, they've asked us to find the prime factors of 140, which can be found using prime factorization. So the prime factors of 140 are 2 times 2 times 5 times 7. And since 2 is repeated 2 times, 2 can be also expressed as 2 squared. So the simplified prime factors of 140 can be written as 2 squared times 5 times 7. In the second question, they've asked us to express 156 as its prime factors. So 2 times 2 times 3 times 13 is the prime factors of 156. Since 2 is repeated 2 times, it can also be expressed as 2 squared. So the prime factors of 156 is 2 squared times 3 times 13. The third question, they've asked us to find the prime factors of 3,825. The prime factors of 3,825 is 5 times 5 times 3 times 3 times 17, and 5 and 3 are repeated 2 times, so the simplified prime factors of 3,825 can be written as 5 squared times 3 squared times 17. The fourth question, they've asked us to find the prime factors of 5,005. The factors of 5,005 can be written as 5 times 7 times 11 times 13. Fifth question, they've asked us to find the prime factors of 7,429, which can be written as So the prime factors of 7,429 will be 17 times 19 times 23. The prime factors of 140 are 2 times 2 times 5 times 7. And since 2 is repeated 2 times, 2 can be also expressed as 2 squared. So the simplified prime factors of 140 can be written as 2 squared times 5 times 7. In the second question, they've asked us to express 156 as its prime factors. So 2 times 2 times 3 times 13 is the prime factors of 156. Since 2 is repeated 2 times, it can also be expressed as 2 squared. So the prime factors of 156 is 2 squared times 3 times 13. The third question, they've asked us to find the prime factors of 3,825. prime factors of 3,825 is 5 times 5 times 3 times 3 times 17, and 5 and 3 are repeated 2 times, so the simplified prime factors of 3,825 can be written as 5 squared times 3 squared times 17. The fourth question, they've asked us to find the prime factors of 5,005. The factors of 5,005 can be written as 5 times 7 times 11 times 13. Fifth question, they've asked us to find the prime factors of 7,429, which can be written as So the prime factors of 7,429 will be 17 times 19 times 23. On to the second question, they've asked us to find the LCM and the HCF of the following pairs of numbers, and we also have to verify that the LCM and the HCF of the two numbers is equal to the product of the given two numbers. So in order to prove that the product of the given two numbers, which we can consider as A times B, is equal to the HCF of A comma B times LCM of A comma B. In order to prove this, we need to first find the HCF and the LCM of 26 and 91. So now we can express 26 in the form of 2 times 3, 13, and 91 in the terms of 7 times 13. So we know that the HCF of two numbers is the product of the smallest power of each common prime factor in the numbers. So the HCF of these two numbers will be 13 because it's common in both. So we can say that the HCF of both the numbers is 13. And we know that the LCM of two numbers is the product of the greatest power of each prime factor involved in the numbers. So the LCM of these two numbers will be equal to 2 times 7 times 13, which is equal to 182. Now we need to prove that 26 times 91 is equal to 182 times 13. So, when we multiply 26 times 91, it needs to be equal to 13 times 182. When you multiply 26 times 91, you'll arrive at the answer 2,386, which is equal to 13 times 182, which is 2,386. In the second question, they've asked us to find the HCF and the LCM of 510 and 92, and we need to prove that the HCF of 510 and 92 is times the LCM of 510 and 92 is equal to 92 times 510. So first we need to find the prime factors of 510 and 92. So the number 510 can be expressed as 2 times 5 times 3 times 17, and 92 can be expressed as 2 squared times 23. The HCF of both the numbers will be equal to 2, and the LCM of both the numbers will be equal to 2 squared times 5 times 3 times 17 times 23. When you multiply the given numbers, you will arrive at 23,460, which is the LCM of both the numbers. Now we need to prove that 510 times 92 is equal to 23,460 times 2. When we multiply 23,460 times 2, we'll get 46,920, which is equal to 510 times 92, which is also equal to 46,920. In the third question, the given pairs of numbers is 336 and 54. So first we need to find the prime factors of both the numbers. So the number 336 can be expressed as 3 times 1, 2, 3, 4. So there are 4 2's, so it can be written as 2 to the power 4 times 7. And the number 54 can be expressed as 2 times 3 cubed. The HCF of both the numbers will be equal to 3 times 2, which is 6, and the LCM of both the numbers will be equal to 3 cubed times 2 to the power 4 times 7. When you multiply the given numbers, you will get 3,024, which is the LCM. Now we need to find the value of the product of 336 times 54, and we need to prove that it's equal to 3,024 times 6. When you multiply 336 times 54, you will get 18,116, which is equal to 3,024 times 6, which is also equal to 18,116. Moving on to the third question, they've asked us to find the LCM and the HCF of the following 3 integers by applying the prime factorization method. So in order to find the HCF and the LCM of all the 3 given numbers, we need to first find the prime factors of each number. So 12 can be expressed as 2 squared times 3. 15 can be expressed as 5 times 3. And 17 can be expressed as 17 times 1. The HCF of the given 3 numbers would be 1, because there are no common terms for all 3 numbers. There are no common factors for all 3 numbers. So the HCF of the given 3 numbers. Moving on to the third question, they've asked us to find the LCM and the HCF of the following integers using the prime factorization method. In order to find the HCF and the LCM of the given numbers, we first need to find the prime factors of all the 3 numbers. So the number 12 can be written as 2 squared times 3. 15 can be written as 5 times 3. And the number 21 can be written as 7 times 3. Since the HCF is the product of the smallest power of each common prime factor, we can notice that the number 3 is common for all the factors of the three numbers, so the HCF of all three numbers will be equal to 3. The LCM of all three numbers will be 2 squared times 5 times 7 times 3. When you multiply the given numbers, you will arrive at 420, which is the LCM of the three numbers. Moving on to the second question, we will notice that the numbers 17, 23, and 29 are prime factors, are prime numbers. So the only common factor for all three of them will be 1. So the HCF, the highest common factor for all three numbers, since all these three numbers are prime numbers, the HCF will be 1. And the LCM of the three numbers will be the product of the three numbers, which is 17 times 23 times 29. When you multiply the three numbers, you'll get 11,339, which is the LCM. Coming to the third question, we need to find the HCF and LCM of the numbers 8, 9, and 25. So the number 8 can be written as 2 cubed, 9 can be written as 3 squared, and 25 can be written as 5 squared. So we can notice that there are no common prime factors for all the three numbers, so the HCF of all three numbers will be equal to 1, and the LCM will be the product of all three numbers, which is 8 times 9 times 25, which is equal to 1,800. In the fourth question, they've given the HCF of two numbers, 306 and 659, which is 9, and they've asked us to find the LCM of 306 and 657. So we know that the product of two numbers is equal to the product of the HCF and the LCM of the two numbers. So we're going to assume that A be 306 and B is 657. So now we're going to substitute these numbers in this equation, in this formula, and we're going to find the LCM. So we're going to take 306 times 657, which needs to be equal to the HCF, which is already given as 9, times the LCM of A comma B. Since 9 and the LCM of A comma B is in multiplication, when we bring 9 over to this side, it becomes division. So 306 times 657 divided by 9 is equal to the LCM of A comma B, which is also 306 comma 657. So we can cancel 9 and 306, which will give us 34. So when we multiply 34 times 657, we should arrive at the LCM of 306 and 657, which is equal to 22,338, which is the LCM of 306 and 657. In the fifth question, they've asked us to check whether the number 6 to the power n can end with the digit 0 for any natural number n. We know that for a number to end with 0, it needs to be a multiple of 5. So we need to check whether the prime factors of 6 has the numbers 5 and 2 within it, because if a number has the numbers, if the number's factors has the numbers 2 and 5 in it, we know that the number will end in 0. So we know that in order to find the prime factors of 6, we know that 6 is divisible by 2. So the prime factors of 6 is 2 and 3. So the prime factors have 2, but it doesn't have 5. And for a number to end in the number 0, it needs to have 5 in it. Since 5 is missing, 6 to the power n will not end in 0. For this, we can also take an example. So 6 to the power 1, since n can be any integer, 6 to the power 1 is equal to 6, and 6 does not end in 0. 6 to the power 2 is 36, and 36 does not end in 0. So thus we can say that the number 6 to the power n does not end in 0. Moreover, we can say that due to the uniqueness of the fundamental theorem of arithmetic, guarantees that there are no other primes in the factorization of 6 to the power n. So 6 to the power n can never end in 0. In the sixth question, they've asked us to prove that the numbers 7 times 11 times 13 plus 13 and the number 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5 are both composite numbers. So in order to prove that, let's first take a look at the first number that they've given, 7 times 11 times 13 plus 13. We can observe that the numbers 13 are repeating. So we can take out 13 as common outside. So we can write it outside the bracket. So we can take 13 outside, and inside the bracket we'll write 7 times 11 plus 1. So when you multiply 13 with the numbers inside the bracket, you'll arrive at the question that they've given. So when you multiply 7 times 11, you get 77. So 77 plus 1 is 78. So the given question can be written as 13 times 78. This suggests that this number has more, it can be written and expressed as a product of 2 or more factors. Thus we can say that this number is a composite number. It's because it has more than 2 factors. Because this can also be written as 13 times 13 times 3 times 2, which shows that this number has more than 2 factors. Thus we can say that this number is a composite number. Similarly, in this 7 times 6 times 5 times 4 times 3 times 2 times 1 plus 5, we can notice that the numbers 5 are repeating. So this suggests that we can take 5 outside the bracket, and we can write, inside the bracket we can write it as 7 times 6 times 4 times 3 times 2 times 1 plus 1. So when you multiply the numbers within the bracket, you'll get 1008 plus 1. So it will be 5 times 109. 1009. So this also suggests that this number can be written as the product of 2 or more factors. Since this number can be written as the product of 2 or more factors, we can say that this number too is a composite number. In the 7th question, they've given that there's a circular path around a sports field, and Sunita takes 18 minutes to drive 1 round of the field, while Ravi takes 12 minutes for the same time. So suppose they both start at the same point and at the same time and go in the same direction. They're asking us to find after how many minutes will they meet again at the starting point. So they've given that the time taken by Sonia is 18 minutes. And the time taken by Ravi is 12 minutes. So we need to find the time taken by both of them to meet again. So in order to find that, we take the LCM of the two numbers 18 and 12. In order to find the LCM of both the numbers, we're going to find the prime factorizations of the numbers 18 and 12. So the number 18 can be expressed as 2 times 3 squared, and 12 can be expressed as 2 squared times 3. So the LCM of both the numbers will be 3 squared times 2 squared, which is 9 times 4, which is equal to 36. So the time taken for both of them to meet again is 36 minutes.